Welcome back for episode 3 of the High School Sport Truck. In this episode, we've got the motor in the truck, but now we got to get everything wired, finish plumbing, get the transmission installed. We're going to show you how to install a torque converter the proper way, and we're going to do our initial test drives, first startup, and maybe run into a few minor roadblocks and show you how to resolve them. Check it out, and we sure hope you enjoy.
We got stuff here, we got things there. This stuff, mind you, I had a buddy take all this apart for me, just in the interest of time. We got a lot of projects going on right now. Sorry, I know this isn't the most intriguing audio right now for the listener or the viewer, but I'm kind of doing something. Well, that goes right on the back of the distributor. And we got grounds on the back of the head. Almost looks like an injector connection. Oh, he goes right here. That's why. It's because it's the Bosch sensor. Oh, knock sensor. That's what that is. Weird spot for a knock sensor, but you know, you do you, boo-boo. Evap, purge stuff. That goes there, that goes there. And that's just about it, ladies and germs, for back here. We should be able to tighten up the fuel lines here in just a second. We're gonna check this because make sure we get the right one. Okay, so I had to double check that the pilot that goes in the backside of the crankshaft is the right diameter and the right depth, because there's some discrepancy in some of the information I found about the later 4.3 motors. This is an LS torque converter, so this motor's an O2, so we'll you can take that information and do with it what you will, but the later 4.3s do take LS torque converters, because the 4L60, the transmission, is LS based. So let's set the depth on it, or check the depth on it, and I'll show you guys how to do that. A touch of surface rust show up on the input before we were able to get it in. It rained last week, so just a tick. So a little PB blaster and a little green Scotch Brite, and let me get a rag and I'll wipe that off. Just a touch, just from the rain last week, or this week. If you look down in here, let's see if you can get some light. You guys see all the splines? In there. See all the different sets of splines? And then you have this keyway on the outside right here. The key with torque converters is making sure they're fully seated. And then if you look inside, behind the seal in here, down inside there, there's a flange, and that interfaces with this. So you've got to make sure that this thing's all the way in with splines here, and then this keyway onto the pump. Because if you don't, you'll jam the front pump into itself when you tighten everything down. So the best way to check that So you never want to put a torque converter in dry. You don't have to fill it, because you are going to have it on its side. Because inside here kind of looks like a jet engine. It's like a fan pushing another fan. It's really the easiest way to kind of wrap your head around it. And the diameter and the pitch of those blades is what dictates stall speed. Factory on these is about 2,000 The highest stall that you could get from GM, in my understanding, based on internet research, is about 2200, and that's an S10 with a 4-cylinder. It was about a 2200 stall factory, 2224, something like that. This one should be 26 to 2800. We don't really want to just stall it to the moon because it is a street driver, but it's a huge performance advantage. I mean, the difference having a stock converter and, you know, something like this, 2800 stall, is, you know, maybe a second at the drag strip in this particular application. We don't have a lot of basis for comparison. We're making a lot of wholesale changes at once, but should make it a little peppier one way or the other. All right, that's better. One, two. Well, that might have been 3. Okay, so the trick with checking these to make sure that it's fully seated, you also make sure it's all the way in tight, and then grab straight edge right behind you. We're at 3 inches exactly, 3.009er, and this is 2 inches, so we have 1 inch of setback right here. Now, go over here. Same deal. Come straight edge, cross, kind of as best as you can, and then we're gonna get a measurement. And we have 2.897. So we have about 1/10 of an inch of difference. Because we subtract our 2 inches out of here. So 0.897, so that's got about 1/8 of an inch. It would be nice if it was a little more. Really, you want a quarter almost, right around a 1/4 inch. So of difference between the two, because you want to have to pull the torque converter back towards the block or towards the flex plate. So we're close. It's probably within tolerance, but let's see if we can get it to seat a little closer. Definitely in there. So same deal. Take our straight edge. Straight edge across. 2.971. And I'm gonna check it over here. This has probably got a little bit of wobble in it. 3.012. 0.62 is a 16th. So we're probably fine. I mean, it's you know, there's a little bit of wiggle, as you can see. So it's definitely not going to be too tight. It'd be nice if it had a fuzz more room, but I think we'll be okay. I think our paint thickness has something to do with it, and those flanges back there, so we'll double check it through the inspection port here when we slip it in here in just a second. So that's how you check torque converter setback.
Under truck bolts.
This stupid transmission jack's been leaking, and then today it just decided it doesn't want to leak anymore. So that's cool. And we're just gonna start a couple bolts. I got them fully seated, or the trans is fully seated. I gotta double check which ones get studs and which ones get bolts. You never want to pull a transmission together with the bolts. Except for maybe the last little fuzz, but I got it to start easily enough already. So if you push on it, it'll close the gap. Okie dokie. So. All right, so we are talking torque converters. Transmission is fully bolted up to the motor at this point. Most of the electrical stuff is plugged in. But we need to put this torque converter in, and I figured I'd give you guys a little rundown. We talked about torque converter setback. If you'll look in here, Roland, if you want to swing around here so you can see what I'm talking about. You will see this is the flex plate, and inside here is the torque converter. So what we want to do, is we'll roll this in so this sits roughly square with it. And if you guys can see, there's a gap. There we go, that's better. There's a gap. That gap is about 3/16 right now. According to the torque converter manufacturer, they want that gap to be between a 1/16 and 5/16, but approximately 1/4 inch. So we are in good shape. Like we talked about, we're an eighth, maybe a little over an eighth. So we're right where we need to be. We're definitely not 5/16, which is almost 3/8. So looking good, looking good. So we're gonna get this bolted up and carry on with the installation. You know, a smart guy would have tightened these fuel lines before I put all the hoses on. Make sure you're using line wrenches when you cinch these puppies down. You certainly don't want to round them off. Because if you pizza and you're supposed to French fry, you're gonna have a bad time. You know, I thought GM left this half metric, half SAE crap behind back in like the 80s or the early 90s. But this thing's an 02. And I'm finding all kinds of junk that's like 9/16, not 13 or 15 or even 14. Like this line wrench specifically. It's a 9/16 in 2002. Pick a team, man. Holler at the 4.3 V6 performance group on Facebook. Thanks for all the support, guys. One of those guys was like, hey, tag me in the video. And so, Justin or something? Jeremy? This one's for you, homie. Yeah. Okay, one more time. Maybe it's a 5/8. So it is a 16 5/8-ish, I think. But the angle is really weird. But that's okay, because I got these crow's foot line wrenches. It's just the kind of crap I just pick up on sale. And then I'm like, one of these days I'll need it. Today's the day. One more time. Get my automotive yoga on. Damn it. Nope. Aha. What up?
There he is. What's up?
Oh, just shooting a little footage. Say hi to the camera.
Hello, camera.
Hello, camera. Uh-huh. There we go. In that middle drawer, in the middle drawer, the top drawer should be a fuel pressure gauge.
Fuel injection pressure.
Yep, that's it. Alright, so we want to be able to check this. What I don't understand is why they put the fuel pressure test board immediately next to the spark plug wires. Like, that just seems like an, asking for problems.
Oh, you need grab.
No.
Clamber on out of there.
Yeah, right? We'll let this ATF start running in. I'm excited for this little truck. I think it's going to be cool. This is kind of, I'm living kind of vicariously because this is what I drove after high school and through college is the previous generation, the GMT 400, but short wide V6 trucks. Had two of them, one automatic, one 5-speed. I actually had an 04 one of these on 20s with a little bit of lowering kit. Back in the day, I bought it new. Had a fiberglass tonneau cover. It was all black. It was a 05 cat-eye truck. 04 cat-eye truck with a V6 and an automatic. Great.
How's it looking?
Just about ready.
Oh, really?
Yeah, I didn't get out here very long ago. So. Whoa. Oh, it's on the brake kit. You need help? No. I'm good. Why not? No check engine.
Purrs like a kid.
Let's go around the block, Ruff. What do you say?
I'd say sounds good.
Hey, the hood still fits. That's cool.
Okay. Man, I was like 23 last time I had a truck like this. Yeah, that's 20 years ago. Well, 2004. So 04. I do love driving short bed trucks in like trafficy areas or whatever. Cause,
Yeah. Not hard hard to park, not hard to get stuck.
First gear. Second gear.
You can already tell it's got a lot to give. Huh?
Third gear. Nice. Second. Oh,
It's me.
All right.
oh yeah, we definitely got to put some 410s or something in this thing. It is way too long geared. Yeah, I miss little trucks.
Always fun.
Always fun. Okay. Motivates forwards and backwards. Fantastic. I think it's these wheels that make it steer so heavy because like the steering feels like it needs more assist. Let's see if see how much stall we got. Oh, nice. All right, sorry. I know it's boring, but I'm just sitting here watching gauges. Sitting on about 200 degrees, 195, which is great. That's what the thermostat is. We've got 40 pounds of oil pressure. Making 14 volts. Moves under its own power. I'll grab my code reader. Let's see what this code's for. Let's see, vehicle diagnostics. 63%, map, coolant, 93. Yeah, it wasn't up to temp yet. Open loop. All right, so we're gonna go back. We're gonna go to view data. Mill status is on. Currently at 700 RPM. Coolant's 190. Short-term fuel trim, long-term fuel trim. Open loop. Interesting. I wonder if it's got bad O2s, because they're the same O2s that were in it when we got the truck with 225,000 miles on it. So it's back. Let's just go ahead and clear codes. Let's do read codes for ABS. Electronic brake control module motor relay circuit. Well, that's not great. It probably needs an ABS unit. That sucks. Oh well. It's not in our scope of work. And I think it had airbag light too. Let's see. Active switch voltage out of range. Yeah, I don't know nothing about fixing no airbags, so I ain't gonna worry about that. Well, it got warm. Let's go see if, not hot, but it got up to temp. Let's pop the hood and look to see if we got any leaks from loose hoses. It's kind of the next phase on that.
All right, what are we hung up on?
Well, the distributor is not, it's fighting me. It's fighting me. So there is a code that keeps coming up. It's P1345, I believe. I can look it back up, but it's whatever it is. Anyways, P1345 is cam sensor crank position sensor correlation. So there's a spec of 0 difference between the two, plus or minus 2 degrees. So what we're running into is this distributor is not really clocking like it's supposed to. Excuse me. Once I get it seated into the oil pump, and it's like I'm half a tooth off one way or the other. So I got to check the interwebs and see what the problem is. See if there's see if I'm the only one, or if it's this aftermarket distributor, which is entirely possible. So, there we go. So it looks like it's lined up here, but the problem is where it bolts down. This bolt hole down at the bottom. See how the bolt only goes in one spot, and that's pretty close, but it's not all the way down. So if I come up one tooth, maybe the other way. There it goes. See how that's not lined up? All right, and we're back. So after a quick research on the internet, I figured out how to get this lined up right. You can see now that the bolt is in, the yellow points match up with our distributor pointer evenly. The issue was there's a slight offset in the gear on the distributor. I went and checked the forums, and as usual, the forum experts were able to help. Thank you, forum experts. And one guy posted that an old school trick that he remembered when you have a locked out distributor like these are, and there's no adjustment, you can drive the roll pin out of the distributor shaft and flip the gear on the shaft. Well, there was just enough offset in the teeth that everything jives exactly where it's supposed to be. So, Yahtzee. Hopefully no more check engine lights. You know, probably good if you, plug the ignition coil back in before you try and start it. That's usually a good idea. Well, she got me now. Pressure, no check engine light. Let's let it run for a minute. Thanks for watching episode 3. We sure are having fun putting this project together for our customer. Man, something like this would have been awesome back when I was in high school. Of course, I had a Z28 Camaro, so, you know. Here's a little preview of episode 4. Here. Ow!
Careful. You okay?
A freaking bolt hanging down. What do you get when you cross a elephant and a rhinoceros?
Don't know. What?
Elephino. Yeah, I did that. Down. Down. Can you sit? No, can you sit? Sit.
Hey,
Who
told you can have my lunch, you little...
We'll put that in the bloopers too.